So at the beginning, last few sections, we've been talking about exponential functions. All functions in mathematics, we need a way to kind of reverse our thinking. For multiplication, we have division. For addition, we have subtraction. Same idea. For an exponential, we have to start thinking about how we can go backwards, okay? So let's focus on number one here. It says, without a calculator, determine or approximate the solution to each equation. 16 is 2 to the 4th. So the power we would put on a 2 to get 16 is 4. So when your x is up in the power spot, to undo it, you want to think about what power could I use to get me that thing, okay? Now, in part 2 here, it says, what power could you put on a 2 to get a 10? Now let's contemplate that for just a little bit, because we're trying to do this without a calculator. I know that 2 to the 3rd is 8. I know that 2 to the 4th is 16 from the last problem. So the 10 that we're looking for means that our x is somewhere between 3 and 4. Now, I don't know what it is. To me, it would be closer to the 3. And one of the things you can do in a calculator is you can start adding a little bit of tenths to the 3. You can try 2 to the 3.1, 2 to the 3.2, 2 to the 3 point, whatever. But you can figure out, what that is. There are going to be some techniques as we go through 4.8 that will allow us to solve them, and especially 4.9. So as we go through this week, we're going to talk about how do we officially solve for this. So we can say that x is bigger than 3, but less than 4. So it's somewhere between 3 and 4. It's not exactly 3, it's not exactly 4, it's somewhere in between. Now, if eventually you're going to know a formula to do it, I know the formula, surprising there, right? And it's about 3.3. A little bit more than that. It's not an exact value, okay? But yeah, okay, let's look at this one. Now, this one's an interesting one because we know how 81 is related to 3. So I'm going to use that fact to help us here, okay? Now, if we think about the fact that this is 1 over 8 to the 4th, we have been talking about our rules of exponents, and one of the rules of exponents says that that's going to flip. If it's in a denominator, flip that sign, change that sign. A negative exponent's job is to denote division. And I'm sorry, I did not write that right. I wonder why you guys were looking at me a little weird there. Okay, so anyway, 3 to the 4th is 81. So 1 over 3 to the 4th is 1 over 81. But if we rewrite that as a negative exponent, and since now we say, what power would I put on a 3 to get 1 over 81, and we showed that 1 over 81 is 3 to the negative 4th, the power I'm looking for would be negative 4. Now you can check your work. You can put 3 to a power of negative 4 into a calculator. Do I get the fraction 1 over 81? And you would, okay? So a negative denotes that it got flipped somehow. The 81 is just going to be, is it a power of 3? And in this particular case, it's a perfect power. 3 to the 4th is exactly 81, okay? So now let's look at the process of reversing this. The process of reversing this is to use a logarithm. The process to reverse this is called a logarithm. So let's talk about what each of these pieces are. This says how many factors of b are in the resulting product m. So our base is that small number notation. This is our answer. And it's always going to equal what power? Okay, so the answer to this one would be 3. What power did I put on a 5 to get 125? 3. So there's some notation I need to show you, okay? So I'm going to write it over here on the side. If we have b to some power equals a number, The way that we want to write it is that the power is always the log base b of that number. So what we're going to practice doing is switching back and forth between this notation. So this is super, super helpful. Make sure you understand that. It's really going to be helpful. Some other things we need to note, okay? If our base is that E number, remember in the continuous interest formula, if it said compounding continuously, that E number popped up, that 2.71828. If we have an E to some power equals a number, then we write that as a log base E of the number equals the power. I'm sorry, let's make this the P. I want to follow the same notation I did on the left there. So the power would be a log base E of the number. But in mathematics, we have a shortcut for this notation. And you might wonder what that was on your calculator all this time. But that is that ln notation. Now, it's just a shortcut. It means log base E. Okay, so that's a special one. It gets us to a natural log. It's ln, not nl. I think they want it to be a log that is natural. Who knows? Okay. And then another one I'm going to write over here is if it happens to be a 10, yes, the power is log base 10 of the number. But that's the other button on your calculator. That would just be a plain old log. You don't have to write the 10. You know how in a square root, we don't show that little index of 2? Because it's the most common type of radical we use. Well, in a base 10, because it is called a common log, it is the log we use most often. If you don't see a little number right here, you're actually working on a base 10 problem. Okay, so the main takeaway from this is that the answer to a logarithm is the power that would be used on this base to get that number. The answer to a logarithm is a power that you would use on this base to get this number. But please make sure you notice that we don't use a log base E notation. You can, it doesn't hurt anything. We're going to use an ln. If it's a log base 10, you don't have to show the 10. You can, it doesn't hurt anything. But it's all about what power does that. What power on that base would give me the resulting product inside, okay? So this is the answer. This is your base. So the base b to a power of p should be the product on the inside, okay? Now it says using logarithmic notation for number 2, let's represent the exact solution, okay? So remember that the power is equal to the log base 2, in this case, of 16. Now that is the answer. But the question also asks us, what power do you put on a 16 to get, or I'm sorry, what power do you put on a 2 to get 16? Okay, so the answer to that is 4. What power do I put on a 2 to get 16? 4. Okay, the answer to a logarithm is the power. You're asking yourself, what power do I put on this number to get the inside number 16? That's why the answer is 4. But this answer, remember, is what power do I put on a 2 to get 10? Now that's the exact answer. Again, we know that it's somewhere between an answer of 3 and 4. We don't know what it is exactly. This is kind of like, you know how, say we get an answer of the square root of 7. Yes, you can throw that into a calculator, but it's not the exact answer because you're going to have to round it. This is the exact answer. that would be somewhere between 3 and 4. The way we'd write this exact answer is the log base 3 of 1 over 81. Now, yeah, we already figured out that the answer was -4, but that's how we undo that exponential notation. So it's super important you know how to go back and forth between those two things. So it's super important to know how to go back and forth between those things. The answer to a logarithm is the power. Look, that's the power. That's the power. That's the power. The answer to a logarithm is a power. What power would I use on that base to get that number? What power would I use on that base to get that number? Yes. So I can't tell you that yet. So right now, the question was, how do you use a calculator? On your calculator, there's really now only two buttons. There's the natural log button, which has to be a base E. There's a common log, which has to be a base 10. So right now, the only calculators buttons we can use are only if it's a base 10 and a base E. Oh, unfortunately, we can't use a calculator at this time to do this. There's a trick. I'll show you how to use a calculator for anyone eventually. We can alter those buttons to fit what we need eventually. For now, it's just going to be our knowledge of powers that's going to get us what we want. And if we don't know the answer, like something like that, we would say, well, that's our answer. I don't know. Just like the square root of 7, if without a calculator, I don't know exactly what that is. So we're gonna be stuck. Those buttons on the calculator only get us so far, and I'll show you how to maneuver that when we get to it. But that's a good question. So this is what I was getting at earlier. So please highlight this thing, that if we have the log base b of x is equal to y is the same as the base b to the y power equals x. You'll notice that the answer to a logarithm is a power. I like to write it like that. I like to write the answer is a power, and I say that's the number. And so our base to our power equals our number. I don't necessarily always use x's and y's so that you can kind of put some words around it, that our power is the answer. Our base is the base in same place as it's always b. And this is the number that we're hoping to get, that x. So please, you have to know how to switch back and forth, because for a while, again, until we have there's a unique formula that's going to allow us to use a calculator, we kind of don't have any way to do it yet, unfortunately. Okay. So some things to remember. The input into a logarithm has to be a positive number. Do you see here it says x is greater than 0? We can't stick negatives in there, that's undefined. We can't stick 0 in there, that's undefined, because there's no way for a base that wasn't ones or zeros to give us something that is negative. So anyway, okay. So it says down here, rewrite each exponential equation in logarithmic form, and if not possible, let's say why. Okay. So let's start with this first one. Our power is x. Our number is y. Our base is 4. So remember, the number equals a base to some power switches to be the log base b of that number equals the power. So you have to know how to switch it, okay? So if there's a 4 base on the right side, we're going to put a logarithm on the left side. So it's the log base 4 of our number equals our power. That's all they want. The log base 4 of that number equals the power, x. And that's as far as they want. They just want us to switch it, okay? Now, let's talk about b, because it's a little funky, okay? So you need to isolate this part. Remember, look at our notation. It is the base to a number. There's nothing in front of that. So the first thing you have to do for part B is you have to divide off the 1.5. Now, when we divide off the 1.5, we get b over 1.5 equals 5 to a power of a. So now what do we know? Well, our base is 5. Our power is a. Our number is that fraction, b over 1.5. So now let's put it in logarithmic notation. I'm going to do it over here on the side. Wherever the base is, the logarithm goes on the other side. So the log base 5 of our number, b over 1.5, is equal to our power a. So you have to know how to go back and forth. You have to know how to go back and forth, okay? Now, if you went and tried to do C, see how there is a negative 32 there. Now, let me show you what you would do. Our base is 2. Our power is x. Our answer is negative 32. So this would be our power is the log base 2 of negative 32. But we can't have a negative in there. There's no way to put a power on a 2 to get a negative number. If it's positive to start with, you can't turn it into a negative, so you don't have some magic powers. So you would say that this is not possible. There's no way we could put a power on a 2 to make it negative. Doesn't work like that. The power itself could be negative, but the numerical quantity cannot be. That number cannot be. D is very much like B. You first have to divide both sides by 3. You have to get that exponential portion by itself. So we get Q over 3 equals 5 to a 2K power. So again, if we use our thinking from before, that's our number, that's our base, that's our power. So wherever the base was on one side, a logarithm goes on the other side. It's like multiplication versus division. So I know that the log base 5 of that number, Q over 3, is equal to my power to 2K. Now, if you were solving for K, you would at this time divide by 2. But to divide by 2, you just wouldn't have any, you can't combine those things per se. So you just kind of put it over 2 and say, well, that's my answer. You can't really go any further. Everybody understand how we're going back and forth between these logarithms? Super important that we can go back and forth, okay? So now we're going to go and we're going to look at what these might possibly be. If there's an exact answer, is there an answer that we can get? Okay, so let's think about what we know for 4a. It says, without using your calculator, try to determine the answer. Okay, now let's think. What power do I put on a 2 to get a 4? That's my answer. The answer to a logarithm is the power used to get this number. So think about the fact, what power would I put on a 2 to get 4? Well, we know that. 4 is 2 squared, so y has to equal 2. What power did I put on a 2 to get a 4? 2. Now, here I would think about two components here. What power do I put on a 9 to get 81? 2, right? But what do we have to do to that power to make it flip? We would have to make it negative. So that's why this one, yes, we need a 2 to turn it into an 81, but we also need a negative to flip it. That's why the answer is negative 2. What power do I put on a 9? Technically, the answer was, what power do I put on a 9 to get that? And that's why the answer is negative 2. What power do I put on a 9 to get that number inside there? The answer to a logarithm is always the power being used on that base. Okay. C here is impossible because of that negative. There's no power I could put on a 3 to turn it into a negative number. Nope, not possible in the real number sense. No way we can do that. So it's not possible. The input in a logarithm always has to be a positive number. The input in a logarithm, that number always has to be greater than 0. Can't be a negative, can't be 0. Okay. Now, this one's kind of interesting. We don't have an exact answer, okay? So it's asking, what power would I put on a 5 to get the number 10? Well, if I put 1 on a 5, I get 5. If I put 2 on a 5, I get 25. So if I put S on a 5 and get 10, it has to be somewhere between 1 and 2. Now, I don't know what between 1 and 2. Seems a little closer to the 1 than the 2, but eventually I'll show you how to find that. So I know S is stuck somewhere between 1 and 2. Again, there will become a time there is an actual formula that we will use on our calculator to help us, okay? Now, hold on to your 4-8 investigation. We're going to continue talking about graphing and domain tomorrow. But could you please go into iMath and open up pre-class M48. Open up pre-class M48 for me, okay? Pre-class M48, open that up, go into iMath, go to your calendar for today. Pre-class M48 is on your calendar. Please open that up at this time and let's get started. A few people were absent on Friday or had early dismissals, so there were a few things you might see on your calendar today. Those are the only things that you can get yourself updated on if you notice anything on your calendar for today. Okay, so pre-class M48 is about exponential and logarithmic functions and how we're going to work back and forth between those notations. So initially here, if you ever want to watch those videos, go for it. They have some good information. But could we please go to our first question? It says, what is the solution to 3 to the x equals 81? Remember, if we can break down that 81 so that the bases match, so we find that exact power that will give us 81. 81 is 3 to the 4th, so x has to equal 4. Now, I'm not sure what's in this block here, but I think it's basically saying that 3 to the 4th equals 81, I would assume, or something of that sort.
It's basically saying, like, which is it, the result of raising 3 to some exponent, the base needed to produce 81 when the exponent is 3, the exponent on 3 needed to produce a result of 81, or the number that is 1/3 of 81.
So the exponent on the 3 had to give you 81. That's the one I believe we want. Okay, thank you. And then finally, it says the solution of the equation 2 to the x equals 128. So if you break down 128, 128 is 2 to the 7th. I always remember 2 to the 5th is 32, and then I just keep doubling if I have to go further than that. So 2 to the 6th is 64, 2 to the 7th is 128, so our answer has to be 7. Now again, I think your numbers are the same as mine, but if they're not, adjust your thinking accordingly so that we can then move on. Now you have a slider on this, okay, but let me kind of show you kind of an idea of what you're trying to do. It says using the applet, see this little purple X? You're going to slide that back and forth, okay? So this one says f of 3.6. So our function, I'm going to write it down here, is f of 1.5 to the x power is what my function is. I'm not sure exactly what your function is. It's the same. So let's take this, slide it around, and we're going to stop as close as we can to an x value of 3.6. F of 3.6 is whatever the height is. So could you guys slide your little button around? Get to when x is 3.6. Can somebody share what the screen says? Yeah, as close as you can get. 4.28. It does allow you to approximate because you're sliding that, and to hit that exact answer is a little funky. Okay. Now, this next one, it says use the applet to find the value of x such that f of x equals 7. Remember, this time your y equals 7. Your height equals 7. So please scroll until your height gets all the way up to 7. And then if somebody could tell me what theirs says. Until your height gets to 7.
The closest I got it was 6.96 and it became 4.79.
Great. Okay. And I think it's going to be pretty forgiving for these particular ones. And then C, again, that's your height is 0.5. Please go to a height of 0. That one was kind of harder. It slid it, and you had to slide it kind of to the left instead of to the right. See if you can slide it over for me and then tell me what you got there. So I think it's somewhere over to about here. So it's negative something. What'd you get? Negative 1.73. Okay. So just they're having you explore. When are they giving you the height? When are they giving you the x value like we've done in the past? So hopefully you've got that working. Now we're going to scroll one more time. This is the y equals 4 to the x is mine. I don't know, is that what yours is? Okay. So it says use the applet above to approximate the value of x such that 4 to the x equals 37. So 4 is our base. It would be the point x37. So again, this is just saying when is our height 37? At what x value will our height be 37? Can somebody tell me? I think it's 4 point something, approximately 4 point something. Can anybody tell me what they got there? So look for a height of 37. Can somebody tell me what their x was?
2.6.
I think they'll probably accept that 2.6. I think that, yeah, that sounds about right. Okay. And then it says check A by, check your answer to part A by entering 4 to a power of that number into the entry box and look at the preview. So if you do 4 to a power of 2.6, you better get a number that's close to 37. It might not be exactly 37, but it's going to be close to 37. Did you guys get your preview that it looks like a number close to 37? Okay. And so C says, let's say we want to estimate what the x is to the equation 4 to the power of x equals 2,000. What is it between? So look what they've told us. 4 to the 5th is 1,024. 4 to the 6th is 4,096. So our answer has to be powers somewhere between 5 and 6. More than 5, but less than 6. And it's because of the fact that 2,000 is stuck between 1024 and 4096. That's all they want there. Okay. Now we're going to jump to this one. So if you look, it says 2 to the a equals b. See, it says 2 to the a equals b. So remember, our a is our input, because look at our x. That's our x. Our b is our output in this particular instance. So in this particular instance, our a is the input, our b is the output. But let's take a look at b. See this inverse notation? That's going to flip it. Our a would be our output of 5, our power. Remember, the answer to a logarithm or the inverse of an exponential is a logarithm. Its answer is the power. So the a is the power, and the b is our number. Same thing for C. A is the power. Our input, 4096, is the number that would sit inside. So 2 to a power of 12 has to equal 4096. So they're just getting you used to reversing things. That's what a logarithm does. And then it says, consider the mathematical statement 5 to the 6th power equals 15,625. This fact represents that blank is the exponent on the base of blank. Okay, 6 is the exponent on the base of 5 needed to produce a result of 15,625. So then here, 4.3 is the exponent on a base of 3, getting an answer that's approximately 112.62. So they're just getting you to pull apart what's your base, what's your power, what's your number. It says that, look what they've given us. 6 to the 4th is 1296. 6 to the 5th is 7,776. So since 550 is smack dab, in between those, the power that we use has to be somewhere between 4 and 5. So then B, we got to find them, okay? So I know that 3 to the 3rd is 27. 3 to the 4th is 81. 45 is somewhere in between. So that means we're in between 3 and 4 as our powers. Now, see, they've given us information. The fraction 1/100th is between 1/125th and 1/25. If you put those into a calculator, you would see it's smack dab in the middle. So this would be between -3 and -2. Now, D, we got to do a little bit of math here. So I think about if I go to the -5th power, that's 1/32. If I go to, I'm kind of going the opposite way. Here, wait. If I go 2 to the -6th, that's 1/64. The fraction 1/58 is between these two. So that means I'm between -6 and -5. Watch your order there, because when I was looking at this problem earlier, if you put -5 first and -6, you have to go in number line order. So if you have my number, that 2x equals 1/58, I just use -6 and -5. Just check what you got. Okay, so that should be done. So now we have one other little thing we're going to talk about today. Oh, good. Okay. Okay, so now go into Google Classroom for me. We're not turning in 5-8 investigation yet because we got stuff to do. I just got to find the one I wanted to go over next. Please go to worksheet 4.8. Tell me if that one's the correct number, if that's number 1. Go into, is that number 2 instead? Go, then we'll call it number 2. I had it number 1, and I think that's the second thing we do. Anyway, that'll be worksheet number 2. Sorry about that. Go to 4.8, worksheet number 2 in Google Classroom. We're going to do a big chunk of it right now together. Oh, that's why we don't have those properties yet. We'll do a little bit today. We'll do the rest, I don't know, I think Wednesday. Okay. But what I do want to do is just this top section real quickly. Okay. Okay. So we're going to do some of the odds together right now. It says rewrite each equation in exponential form. So remember, if we have the base to a power equals a number, that's the same as the power equals the log base b of that number. Now, my formatting on this particular it did some funky things. So this 11 should go over there. This 7 should go over there. Those ones are okay. This is a 1/2. Hopefully you can see that. I don't think other ones were shifted. No, I think we're okay. Okay, so let's do these real quick. We're going to put these into exponential form. So we know that that's so messed up. Okay, never mind. I have to write a whole new problem. Okay, the log base 11 of 2 equals 120. No, of 121 equals 2. There we go. So that's what should have been on the page. It got all messed up. But anyway, so let's fix this. So our number is 121. The base of 11 goes to the other side, and the power is 2. Okay, so our base is 11. Our power goes up in the power spot. Our number is what 11 squared is equal to. Okay. So scratch 3 out completely because that makes no sense whatsoever. The rest I think are okay. Okay, let's rewrite this as the log base 7 of 49 equals 2. So our base is 7, our number is 49, our power is 2. So take off the logarithm, write your number, 49, then write your power 7, or I'm sorry, your base 7 to a power of 2. Okay, so take off the logarithm, put a base 7 on the other side, our power is 2. Now in 5 and 7, we're going to go backwards. We're going to put it in log form. So for this first one, our base is 81. Our power is 1/2. Our answer is 9. So I know that the power 1/2 equals the log base 81 of 9. Now that's basically just saying that the square root of 81 is equal to 9 because a square root is represented by a half power. Now you might recognize 7. Our base is 7, our power is 2, our number is 49. So our power of 2 is equal to the log base 7 of 49. And then let's do 9 and 11. It says rewrite each equation in exponential form. Our power is the y. The answer to a logarithm is always the power. Our base is the x. Our answer is 191. So our answer of 191 is x to a power of y. Our answer of x is equal to our base to a power of 19. Is everyone seeing how these get pulled apart and go back and forth? Okay, let's do 13. We're putting it in log form. If our base is on the left, our log is on the right. So our power of y is the log base x of 178. Our base is x, our power is y, our number is z. So our power is log base x to a number z, or of a number z. And I think the rest of this worksheet, you could try the first page if you'd like. Yeah, the rest, we don't know the rules yet. We're going to get there. Okay. One says, use logarithmic notation to represent the solution in the following equations. If there is no solution, enter DNE. Okay. So all we're going to do here for this first one is we have to identify what's our base and what's our number. So our base is 6. The answer to the log is the power x, and our number is 62. So we're going to have to use our little yellow button here. We're going to have to go to the functions. See this log base n. Now the reason they have a log base 10 and a log base e, none of those are 10s or e's. So we have to use this log base n. Okay. And I think we have to put in the number 6 right here. I don't know how to do that. I don't know if this is going to work, guys. So I use the underscore button to make it go down in the 6th spot. I'm not sure. And then the answer is 62. Let's see if that's what they wanted. Yeah, see how they did a log base of 62? Let's see if they like that. Yeah, that's good. Okay. So this would be a log base 6. So I think we could just type log underscore 6. And we're going to put 1 divided by 1296. And then this one, does this one work? Does this one work? Can we put a number on a 3 to get a negative number? No, so just type D and E. So if it's a different base, I think you can use the underscore on your keyboard to make it indicate what your actual base is, and then you can put your answer in parentheses. Okay, I'm moving on to question number 2. Use logarithmic notation to represent the following. If you don't have an answer, put DNE. Okay, so this time our base is 4. So I'm going to hit log underscore 4. And in parentheses, I'm going to put the 55. Here, I'm going to put log underscore 4, parentheses, 1 over 16. Now that's a one that is negative 2. See, it does show negative 2. So if it's an exact answer, you could probably just write negative 2. And then this is a DNE. Okay, let me see if they get more difficult or how they change. Rewrite an exponential. Rewrite an exponential. Let's do question 7. It says, what, without using a calculator, determine the answer. Think about number question 7a. What power do you put on a 7 to keep it to 7? 1. Answer is 1. What power do I put on a 2 to make it the number 8? What power do I put on a 2 to make it an 8? 3, right? And then here, what? Think two steps for this one. What power would I put on a 4 to get 64? That would be 3. But what do we have to do to that power to make it flip? Make it negative 3. Can we do question 5? Says, what is the answer? Okay, so y is f of x. So f prime of y, I think, is the log base 6 of x is what they want. Let's see. We'll have to come back to that one. Okay, you guys have a good one. Thanks. Oh, that would be the log base 6 of y, I think. There we go. Okay.